Chapter 4, Section 8 in the 8th grade textbook is entitled Pythagorean Theorem. The Pythagorean Theorem is all about right triangles. It's about finding the missing side in a right triangle given two of the sides. The reason it fits into Chapter 4 is we've been talking about squares and square roots. And that's really what the theorem is about, is it's about squares and square roots to find that missing side or to use that information to find the missing side. So it fits really nicely in with Chapter 4 because it has those concepts involved. So let's start off with the definitions here. Pythagorean theorem: in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. In a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Now, if you don't know what hypotenuse and legs are, that definition doesn't mean anything to you. So let's get those out of the way and then we'll talk about the definition. Leg, in a right triangle, that's a side adjacent to the right angle. In a right triangle, it's a side adjacent to the right angle. And the hypotenuse, in a right triangle, that's the side opposite the right angle. The hypotenuse is the side opposite the right angle in a right triangle. Okay, so we've got a right triangle. Remember, what makes a right triangle? Right triangle is it has one right angle. There's no other properties that absolutely have to exist just based on that definition. It just has to have a right angle. You've got two sides that together make that right angle. Those are called the legs of that triangle. And then you've got the other side, the third side, the one that does not make up the right angle. It's across from the right angle in a drawing, as you'll see in a minute. That's called the hypotenuse. And what the theorem says is that if we square the lengths of those two sides that make up the right angle, that's going to be equivalent to that hypotenuse, that third side, squared. That's all the theorem says. And that's what we'll apply here. Now, as you're looking at 1a, though, or at least the triangle for 1a, that the squared information is helpful for us, but the sides of the triangle are never going to be marked the units squared. They're always going to be marked just regular. A, B, or C is how we define it in a formula. So they're not going to be marked A squared, B squared, or C squared. All right, they're just going to be marked A, B, or C. So whenever we figure out something squared, then we have to get back to the regular unit. And the way we get back to the regular unit is by taking the square root. So squares are parts of the formulas. Square root is generally how we're going to end up finding our answer, and that's how this fits in with Chapter 4. Pythagorean formally is a squared plus b squared equals c squared. And I'm going to go ahead and scroll down and we'll talk about what that means again really properly here in question number 1, where it's asking me to find the length of each hypotenuse to the nearest hundredth. Okay, so in question number 1 here, question number 1, they've given us our right triangle. Again, what makes it a right triangle is it has this right angle right here. The two sides that make up the right angle are called the legs of the triangle, and the third side is called the hypotenuse. The hypotenuse, as I said in the intro, is across from the right angle, which you can see I've drawn in. I would always recommend you identify the legs first, the two sides that make the angle, the right angle, and then just fill in the third one, the hypotenuse. The formula says if I take a leg and square it, and take the other leg and square it, that's the same as the hypotenuse squared. Now, Pythagorean formula, really formally, says a squared plus b squared equals c squared. If you look it up in a book, that's probably what you're going to find. What you have to know is that a and b, and you can see I've kind of written it to match up, a and b always represent the legs. How you mix these up doesn't really matter, because if I pick the one side to be a and the other side to be b, or I do it the other way, when I square it and add it up, the result is going to be the same, so it doesn't matter. Right? The third side is always the hypotenuse, and that one's always c in the formula. That one you do not get a choice. The hypotenuse is always c. The hypotenuse in a right triangle is also always the longest side. So if I were to just give you three sides and you were saying which one's the hypotenuse, you could look for the biggest number. Of course, if I gave you all three sides, though, you wouldn't have to do the theorem, because the theorem is all about finding that third side. So as we look at the triangle, that side that we've already labeled the hypotenuse is marked C for that very reason, because in the formula it has to represent C. So these two guys here, the legs, are going to be A and B in the formula, which you can see again is right here. Again, you can pick any order you want for them, but they picked A to be 4 and B to be 5. So it says I'm going to square each of those guys, 16 and 25, and that's going to be the same as the hypotenuse squared, or C squared. Well, that means C squared in this particular question is going to be 41. Well, problem is if we look at the triangle here, that's not marked C squared, that's just marked C. So now somehow I've got to take my work and get this to go from C squared back to C. And here's where your square roots come into play. Remember, square and square roots are opposites of each other in just the same way that addition and subtraction are opposites of each other, just like multiplication and division are opposites of each other. So, if I want to get from C squared back to C, what I have to do is take the square root. So at this line right here, I'm going to go ahead and take the square root. Now, the thing is, though, that this is just like solving an equation. I can't do something on one side of the equal sign and not do it on the other. So since I'm taking the square root there, I also have to take the square root right there. When I take the square root all the way across, then this is how I get back to C. The square root of 41 is going to be my solution. When I take the square root of 41, that's 6.4031242237. They've asked me to round to the nearest hundredth, so they've written 6.40. So C must be 6.40 units long. Now, the other question you might have is, why did they write 6.40? Isn't 6.4 the same thing? It is, but the question has asked me to round to the nearest hundredth. When they ask me to round to a certain place value, I want to make sure that my last digit, unless it's physically impossible, is in that last place. And indeed, in this particular question, by writing the 0 there, that shows that I'm rounding to the hundredth place. Now the next question is going to let me practice this again. So let's go ahead and scroll down and practice some more here. Here's a triangle, but it's on a coordinate grid. And we're going to find the length of the hypotenuse, find the length of C once again here. So we can see very easily that we have two sides that make the right angle. This side and this side make that 90-degree angle right here. So these two sides are going to be my legs. This side is going to be the hypotenuse. Now, what's different about this question, where people want to make or could make a mistake, is they say, okay, well, I can count off how many units this is long. Yes, you can. All right, I agree. You can count off how many units this is long. Yes, I agree. And you can see that's exactly what they did. They figured out that this is 9 and this is 12. So the legs are 9 and 12. But then what people want to do is they can go, oh, well, I can see that goes pretty much across a box, that goes across a box, that goes across a box. So that must be 3 units. No. All right, that is not how this works. Or the multiplier here is, as you can see, a multiplier of 4, so 12 units. That's not how this works. Going across a grid square diagonally is not the same as going straight up and down or left to right one jump. It's actually a little bit longer than that, and we could actually use the theorem to prove that. So you can't just count, though, when it's laid on top of grid boxes like this and go, well, it goes across 3 boxes, so it must be about 3, so my answer is 3. No, that's not acceptable. You have to use the theorem. Don't make the mistake of getting fooled into counting and say that's got to be my answer. Since we figured out the 2 legs here, 9 and 12, we're going to plug that into my formula. Again, the formula says if I take the lengths of the legs and square them, 9 squared and 12 squared, that's going to be the same as my hypotenuse squared. The hypotenuse, again, is the one I don't know. Again, it's the one that doesn't make the right angle. That's how I know this is the hypotenuse. So 81 and 144 is the same as the hypotenuse squared, or 225 is the same as the hypotenuse squared. But remember, in the triangle, this here is not c squared. That's really just c. So you've got to get back from c squared back to c. And the way we do that is to take the square root, because squares and square roots cancel each other out. So we take the square root all the way across here to finish. When I take the square root of 225, the result is 15. So this side here, the hypotenuse, must be 15 units long. And again, remember, this, the hypotenuse, c, always has to be the biggest number. So that being 15 makes sense, because if the other 2 sides are 9 and 12, my answer has to certainly be bigger than 12. All right, let's go ahead and take a look at number 2. Now, this is still the Pythagorean theorem, but as you can see, what's different here, looking at this triangle, is now they're asking me to find b. Still works with the formula, but we have to work a little bit differently. Remember, the 2 sides that make the right angle are the legs. So these 2 guys are the legs. So I do know one of the legs. And this other side here, that's the hypotenuse. And again, the hypotenuse is always across from the right angle. So this guy here is c in the formula. Okay, so we know this guy here is a leg. He's a or b. It doesn't matter. This guy here, 25, he's the hypotenuse. That's c. All right, so let's plug some numbers into our formula. The first thing we've got is one of the legs squared. They decided to call this a, so a is going to change into 7. So legs squared plus the other leg squared. Now, we don't know that guy, so that's just going to have to be b squared right now. And that's going to equal the same thing as the hypotenuse squared, c squared, 25 squared. Well, let's simplify what we can in this line. 7 squared is 49, 25 squared is 625. So it says 49 plus b squared equals 625. Now, if this said x, I don't think anybody would have a problem, because that's me solving an equation. We've been solving equations for a long time in middle school math here. All right, to solve this equation, I'm going to isolate the variable. I'm going to kick all the numbers to the right side of the equal sign. So that's why you see them subtracting 49 now. And so x is 576. But it's not x. It's b squared is actually what this says. So b squared equals 576. Well, remember, looking back at this triangle, this side isn't labeled b squared. It's just labeled b. So to get from b squared back to b, now what you have to do is take the square root. So I'm going to take the square root all the way across here. Square root of b squared is b. Again, squares and square roots cancel each other out. That's why that works. Take the square root of 576. That's 24. So this side here must measure 24 units. And that is actually correct. You can now test it. Do 7 squared and 24 squared and add it up. It should be the same thing as 25 squared, which is 625. Remember that this side here, the hypotenuse, is the biggest number. So 25 is the biggest number I can have on this triangle. So if I would have gotten that b was 27, I would have known I did something wrong, because this side, 25 being the biggest number, everything else has to be less than 25.